There has been a lot of talk in the news about the star Betelgeuse. And this video will be talking about Betelgeuse and the amazing moment of what you're seeing when and if Betelgeuse goes supernova, as many astronomers expect it eventually will. Betelgeuse is a star, obviously. It's a star in the Orion constellation. And it is a pretty bright star. It is a red supergiant. And what that means is that Betelgeuse is nearing the end of his life. And stars, when they near the end of their lives, basically have a number of paths. But two of the more well-known paths is that it will either go supernova or it will become a black hole. Now, both events are amazing, but black holes can't be seen because black holes absorb light. And therefore, no light can escape a black hole. And therefore, unless you have equipment that in essence looks for other things that a black hole gives off, it can't be seen by non-astronomers. Supernovas, on the other hand, can be seen by non-astronomers. And this is a huge, if it occurs, a huge astrological event because, as I mentioned, Betelgeuse is the 11th brightest star in the sky. That in and of itself, out of all the stars that you see, is amazing. So if it does go supernova, you will be able to see it at night. Quite possibly, you might be able to see it during the day. And therefore, these type of events do not happen that often. And therefore, if you see these events, appreciate that these events are quite rare, especially for a star of this magnitude. But the also amazing thing is that if the star does go supernova, it will have already occurred. And what I mean by that is, on the screen, you see a 3D rendering of Earth and the sun. That distance from the Earth to the sun is around 91 million miles. That is pretty far. I will not be using miles for the most part. I'll be using a more accurate measurement, which is an astrological unit. And what that is it is the distance between the Earth and the sun. So 91 million miles is one astronomical units, or an AU. Betelgeuse is around 700 light years away, or 13 AUs. And it takes light time to leave a star and go or reach our eyes. Because basically what happens is stars use what's known as nuclear fusion, which is basically it fuses hydrogen to create, or it fuses hydrogen, and that process creates helium. And that process basically fuels the star, which in essence creates light. That light has to leave the star and travel to our eyes. Now you might be thinking, well, isn't light instantaneous? No, it is not instantaneous. It might seem instantaneous, but that is because light travels really fast. Light travels basically 186,282 miles per second. That's how fast light travels in a vacuum. And even if it's not in a vacuum, it still travels pretty fast. And therefore, what that means is that when you turn on light, or it seems to be instantaneous, but that light just travels so fast from its source to your eyes? Well, space is really big, it's really wide, and it's really empty. There's not much stuff, more or less, in space. And therefore, light has to travel great distances from stars to reach our eyes. And it's the same case from our sun. Now, our sun may be one astronomical unit or 91 million miles away from our eyes, but the distance or the time it takes from light, from which the star has performed nuclear fusion, and that process ends up basically creating light and energy, and then it leaves the sun to our eyes, takes 8 minutes. So what you're looking at when you look at the sun was basically light generated by our sun 8 minutes ago. If you think on this further, what that means is that if something would happen to the sun, let's say the sun just disappears, what would happen is the light that has left the sun will take 8 minutes to reach our planet. After 8 minutes, whatever would happen with the sun will then reach our eyes, because now light's no longer being generated. It has taken light 8 minutes to reach our eyes. So when you look at the sun, you're looking at the sun 8 minutes ago. And that logic applies to all the stars. Some stars are millions of light years away. So when light was generated by those stars, the Earth was still, the solar system might not have even been formed yet, but it has taken light that long from that star to reach our eyes, because the universe, space, is very, very, very huge and very, 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 very wide. It is hard to fathom how big space actually is, but it makes it more amazing, because when you look at the stars, what you're doing is you're looking into a time machine, because the light that has reached us came from so long ago, and that has happened with Betelgeuse. So when you hear the news reports say Betelgeuse is about to go supernova, that is not necessarily true, because it takes time for that light from Betelgeuse to reach our eyes, and it takes around 700 years. So if Betelgeuse goes supernova this month, next month, a few years from now, 10 years from now, it would have occurred 700 years ago. And it has taken that long from the light from that star to reach our eyes. But enough about the brief intro to Betelgeuse. Let's do some exploring. So Betelgeuse, in case you want to see Betelgeuse, is in the constellation of Orion. Now, Orion is, at least in the northern hemisphere, is mostly visible during the winter. And Orion is a pretty big constellation. And it's not that hard to see if you have a clear night. But the key thing about Orion is that if you see Orion, in order to see Orion, the best thing to look for is Orion's belt. Now, what do I mean by Orion's belt? So let's go to constellation figures. All right. Orion can be viewed. Let's see if I can find our target. Okay, so that's Orion. Now, in the northern sky, it might be tilted. It might not look as it does on this program. But as you can see, this is Orion. And the best way to look for Orion is to see what's known as Orion's belt. So that's Orion's belt right there. Betelgeuse is in the shoulder of Orion. So this is Orion's belt. And this is the easiest way to see Orion. You basically will see 3 stars that are almost equal distance apart, and they'll be in more or less a line. And these are pretty bright stars, so you can't miss Orion if you look for it. But Betelgeuse is in the shoulder. So Betelgeuse is actually right here of Orion, of the Orion constellation. And that is our target. And this program, we will be able to travel to Betelgeuse. So we will be able to go 700 light years instantaneously. And let's do that now. And here is Betelgeuse. Now, the reason Betelgeuse is on the verge of going supernova is because it is late in its life. So the question might be, well, wow, how come do stars actually die? The amazing thing about astronomy, the amazing thing about this world is that nothing lasts forever. Things are born, things die. And stars go by the same logic. They are born, they live their lives, and then they die. Betelgeuse is a red supergiant. And basically what has happened is, as I mentioned earlier, stars use nuclear fusion to generate energy. They take hydrogen, they in essence fuse it to create energy, and the byproduct of that is helium. Well, stars only have an infinite amount of hydrogen. Now, they have a lot because they last millions and millions of years. But eventually, a star will begin to run out of hydrogen. And when that occurs, it will in essence struggle to do so. And the star will begin to increase in size. Where ultimately it will begin to run out of energy. And once it begins, or run out of hydrogen. And once it begins to run out of hydrogen, it will in essence do one or two things. It will collapse on itself and formulate a black hole or dwarf, or it will release all its remaining energy and it will become a dwarf. In essence, it dies. The star will die. And that is what's happening to Betelgeuse. Now, when it happens, it has already occurred. Remember, because it takes time for the light to leave the star and reach our eyes. So when we see it, would have already occurred. But this star is dying. And when it dies, it will go supernova. So it will, in essence, release everything that it has, and it will die. And that is what we are looking for. But remember that it will take time for it to reach our eyes. Now, there are different phases that a star goes, or different stages a star goes through in its life. Now, the fact that it is a red or a supergiant is based on the Morgan-Keenan classification scale. So you have a dwarf, a subgiant, a giant, a bright giant, and a supergiant. And remember, Betelgeuse is 700 light years away, but because it is late in its life, it will eventually collapse on itself and create a supernova. And that, by the time it reaches our eyes has already occurred. And that is the amazing thing. Because remember, when you look at the stars, you're looking into the past. That's what, for the most part, astronomy is. You're looking into a time machine because you're looking at objects or energy or light that has traveled millions and millions of years to reach our eyes. And those objects might not be in existence today because stars do not act in real time. Stars are vessels of the past. And therefore, when you look at the night sky, you're in essence looking into the past. And now let's go back. And that is not working. That's not good. Apparently, I can't get to Earth from Betelgeuse, but I can get to the sun. And now we're back at the sun. Aren't computers amazing that I can travel 700 light years in about 2 seconds? And from the sun, I can get to the Earth. And now we are back. And therefore, I hope you have enjoyed this brief lesson on Betelgeuse, the importance of such an event, the rarity of such an event, and where to locate Betelgeuse if you want to see it before it goes supernova, and where the Orion belt is, and the wonderful things you can see during this event. This is Science Talks, and I will talk to you soon.